Okay, this lesson is evaluating logarithms, and we've seen a little bit of a logarithm stuff so far, but today we're actually going to try and evaluate them both in our head and using your calculator, so we finally get to see what that log button does. So here we go, evaluating logarithms. A little warm-up exercise to start with. Express each of the following in logarithmic form. So we've been talking about expressing things in exponential versus logarithmic form, something like this: 5 to the power of 2 equals 25. What we want to talk about is how to express that in logarithmic form. And when you're first learning about logarithms, I think the most important thing is to know how to say it first. That is, if I'm going to write log of something, it's going to be the power, the exponent I put on something. So here, I'm putting an exponent on 5. 5 is what I'm putting the exponent on. That's my base. So when I go to write a log, it's going to be log base 5. Now, the second part of writing that answer is what result you get, and here you get result of 25. So this in logarithmic form is log base 5 of 25 equals 2. Now look carefully here at this 5. Here it's saying log base 5. The power I put on 5 to get 25 is 2. These two statements that were written under part A here are equivalent. They're saying the exact same thing. The first one says the power I put on 5, there's 5, to get 25, over here, to get 25 is 2. And here, said the exact same way. The power I get to put on 5 to get 25 is 2. Let's try another one. 4 to the negative 3 equals 1 over 64. Now let's remember what negative exponents do. We're talking about, instead of multiplying by 4 3 times, we're talking about moving that to the denominator and dividing by 4 3 times. Well, what does that look like? It's still 4 to the power 3. 4 times 4 is 16, times 4 is 64, but because of the negative exponents in the denominator. So negative exponents aren't negative numbers per se. You're not going to end up with a negative answer out of it. What you're going to end up with is an answer in the denominator. So here, the power I put on 4 to get 1/64 is 3. So to write that in logarithmic form, the power I put on 4 to get 1 over 64 equals negative 3. How you say it is how you break through with logs initially, is being careful to say it carefully. The power I put on 4 to get 1 over 64 is negative 3. So now, using that knowledge, we're going to evaluate each of the following. What is this asking us for? Say it carefully. Say it with me. The power I put on 3 to get 27. The power I put on 3 to get 27. Well, what power do you put on 3 to get 27? And you might know it in your head, and that's fine. But what I really want to talk about is what do you do in your calculator to get these answers. So we know the answer is going to be 3. But if you didn't know it was 3, what power do I put on 3 to get 27? Well, let's say I didn't know. So I put on 3 to the power of 2. I think maybe the answer is 2. Backspace. 3 to the power 2. Answer 9. It's not 9. Okay, so let's go one bigger. 3 to the power of 3. Oops, backspace, backspace. 3 to the power of 3 equals 27. Okay, so the power I put on 3 to get 27 is 3. So the answer to log 3 of 27, I got to get all the way back to that point in the PowerPoint. Here it comes, all this stuff again. Power put on 3 to get 27. What exponent must I apply on 3 to get 27? We try it in our calculator and I get 3. Yeah. Okay. One more. What power do I put on 5 to get 1 over 125? Now, it's got to be a negative power because we're ending up in the denominator. So the question is, what do I put power to put on 5 to get 125? Well, 5 to the power 2 is 25. 5 to the power 3, 25 times 5. Oh, that's 125. Okay, so we're talking about negative 3 here. Okay, so not hard to figure out what the exponent's going to be as far as a number is concerned. 5 to give 125, that's 3. But if it's in the denominator there, that would mean negative 3.